Alrighty. Well, I'm sure people will join in as we go along. We usually get people showing up later, but I'm gonna go ahead and get started here because there's quite a few queries, and I'm gonna do something I've never done before in this class. I'm gonna talk about how to write stored procedures. Um, so that should be fun. So before we get any, Mike, you have any questions about last week's assignments or anything pertinent?
I don't believe so.
Yeah. Well, then I'm gonna just jump into this week's code. This week's code is about using subqueries. Subqueries are great to use. They're a way to have more of a dynamic flair to your queries, so you're not putting a value in there. Um, they're still somewhat static because you're still pulling from a specific table, not having the user add data, add input into the query. So I'm just going to go through about 10 examples of subqueries in different varieties. And then I'm going to talk about how to create stored procedures. Because what a stored procedure is, it's a predefined piece of code that you can put values into and have it spit out values. So it's kind of like it's a very versatile and dynamic query. Okay. So the first one here, we're just using a subquery that returns a scalar value. I'm just getting the averages of rental rates from the films table, and then I'm finding out which films have are above average in the rental rates. So if I just run this one by itself, it tells me the average is $2.98. And so I'm looking for anything that's over $2.98. So again, this query here is run first, it gets the value, and then this query is run after that to get that the rest of it. Um, this one's a little bit more complicated here. We've got I'm just getting the first name and last name from customer, where the address is in, and I have a subquery here. I've got quite a subquery here. I've got a subquery within a subquery. So you can nest subqueries up to I think 5 or 6 before it gets a little unwieldy. So this is my first select query. I got select first name, last name for customer, where address ID in, and then I've got this subquery here. Select address ID from address where city ID and is in. Select city ID from city where country ID, and then I've got select country ID from country where country is in Canada or Mexico. So I've got 1, 2, 3 nested subqueries into this query, and it's just all to get the Canada and Mexico thing. Not the best way to do it, but a way to do it. And when I run this, so what happens is it goes reverse order. This is the first query that's run, and then this query is run, and then this query is run, and then this query is run. And we get our answers. In this one, I'm using a subquery in place of a table in a join statement. So we get first name, last name, and total spent from customer, and I'm joining this query right here. Select customer ID, sum of the amount, and its total spent from payment group by customer ID as CP. So I'm just using a subquery as an instead of a table to get the value I want. Hey Taylor.
Hey, how's it going?
Good. Just going over the queries for um, how to use subqueries in a bunch of different ways, and then I'm going to talk about how to create store procedures, which I've never done before in this class, but
Sounds good.
I feel it's necessary at this point. Because like I've said before, like these are when using subqueries, it's more of a dynamic query because we're getting to this will not always be the same amount because that table is changing constantly, but it's still not allowing user input. So get this. Okay, next one here. Um, I'm doing a where exists. So I'm first name and last name for customer, where exists. I'm selecting the top one from rental. I'm selecting true or false from rental, joining inventory film, and where the where the customer ID matches and the replacement cost is greater than $25. I'm looking for any customer who rented at least one film with a replacement cost over $25. Okay. Now here, getting a little more complicated. I have a subquery in my select statement. So I've got select count from rental or customer ID, our customer ID equals C customer ID. So where rental equals customer. Now, this is a join per se because I've got the customer table here and I've got the rental table within the subquery, but they'll talk to each other. So I can't run this one on its own because it doesn't recognize that because it's not part of the entire process. But what this does is it shows the customer's name and the total number of rentals that they've done because of this. So it's kind of this a weird join. I don't.
So even though it's a subquery, because it's a select statement, we don't have to use the group by. We can still use.
Well, remember this is an aggregate.
Oh yeah, that's right. That's right.
Mm.
Okay.
That's why we didn't need to use the group by
Okay.
because and there's no reason that this worked. Here we got first name, last name from actor, where it doesn't exist. So this is where I'm pulling out. This tells me what actors are in movies that are rated R, and then I turn up the last name because I'm joining the actor ID with the actor ID from film actor. So it's going to turn a one or a zero. One means they're in an R-rated movie. Zero means they're not. And then it's just going to show me the first and last names of those actors based on this because of this join in here. There's only three of them. These are ways to get around joins. You do the same things as a join. I'm just using this to show you different ways you could technically use a subquery and the versatility of it. Here I'm looking for a title and replacement cost from film where the replacement cost is greater than anything that shows up here under sci-fi. So this is looking for any film in sci-fi as long as the replacement's greater. And I got about 35 of them. This one, so they're any, and I got all here. So I want to find out what films in the category family have a replacement cost greater than the highest replacement cost in this table. And again, because this joins the film table here, if I run this on its own, I can. So I'm gonna look for the highest. I think 25.99 is probably the highest. So I'm looking for anything that's above 25.99 in this. And there's none of them. Any questions so far? I don't want to be going too fast. Okay. We can use subqueries in update statements. Okay. So I'm updating the film. I'm setting rental rate equal to rental rate one time times 1.1 and where the film ID is this. And I have limit one, so it's only going to do the first one. It's only going to do one of them. And limit one means I'm only going to update one of them. So that limit one, remember, limit one stops how much gets done. So in a select statement, when this runs, it's not going to. When this is there, it's only going to do the top one response, and this will only update the first response. But I'm going to do the in transaction anyway because I want to make it happen. So then I run this. What happened? Oh, sorry, I forgot this here. There we go. Oh, MySQL, my version of MySQL doesn't support this yet. So let me just get rid of this. My limits here. Oops. Sometimes I code and forget I'm doing MySQL. Try this again. There we go. Oh, I could have done that. I could have a limit one here. That should work then. Anyway, over here, I'm using like it doesn't support limit and subqueries. Here I'm deleting from actor where the actor ID is not in this from film actor. So I'm trying to delete from film actor. I'm trying to delete any actor from the actor table who's not in the film actor table. So I want to delete any actors who aren't in films. Okay. And so 2 rows were affected. Let's roll them back. Okay. Any questions on this? All right. Let's talk about creating procedures. So a stored procedure is a piece of code. Think of it as like a function. It's not the best word to call it, but it's a piece of code that you save in the SQL database that you can call by using its name. You can pass in a value, and it will return information for you. So you don't have to run this code again. So the benefits of this will be that I think I told you before, but whenever you run queries like this, it compiles it on the fly. So every time you run this, it compiles it, which means it takes it from the language we see in Transact SQL into machine code and then does all the things for the database. You're talking milliseconds of milliseconds to run. But when this one query is running 50,000 times a minute and it has to compile every single time, you're not only taking up a lot of space, you're not taking like a lot of cycles on the CPU and a lot of space in RAM, but you're taking a lot of space on the drive as well because you keep pulling this stuff out and pushing it back in. When you compile a stored procedure, this code stays in the database at all times and it's already compiled. It has something called an execution plan. It's not something I can show you here in MySQL because I don't have the tools in MySQL to show you. But basically, it's a flow chart. If you're in Oracle, they're called explain plans, and in SQL they're called execution plans. It's basically a flow chart that the database uses or the engine uses to run the query. So it knows how to do it, why to do it, where to do it, what indexes to use, and so on and so forth. The syntax is pretty easy. The words are create procedure, give it a name. Naming convention usually starts with an SP. Here's the variable. So you're inputting a variable called P rating. It's going to be a varchar 10. And you use the in because it's going in. Begin and end. Select title, description, release here from film where rating equals P rating. So if I run this, it creates the procedure, and then I can run the stored procedure. In MySQL, the term is call. call the store procedure and give it the value goes into it. And we can change it to R. So you can run it with different values without having to rerun the query. So there's a huge value to this when you're programming because a lot of times when front end developers do it, they'll put this in their code on the website. They'll embed T-SQL code within the C# or the JavaScript or the whatever language they're using. So the problem with that becomes not only is the code being compiled on the SQL side every time it's run, there's something in the engines of database that they know that the query is coming from somewhere else. It's not being executed locally, and it's handled a different way. And it's not handled as elegantly as one that's done within the scope of the server. So you've got your web server that has the code on it. It's running the code there. It's sending it over to the SQL server or the MySQL server. It's running the code there. It's a little clunkier than if it's run locally on the you execute on the actual machine. Also, there's more of a chance of because when you're running a website, you can right click it and go to the source code of the website. You can go and get the code from there if the developer didn't do it right. This protects your code. This also protects what's going in. Are you guys familiar with the term SQL injection?
No, I'm not.
Yeah.
You are. So for Taylor, SQL injection is when I'm gonna stop sharing for a second. I got to find this one meme. It explains SQL injection so well. Hang on a second.
It's something I messed around with, like learning a little bit a while
Yeah.
ago because it's pretty interesting.
So here's let me reshare. I found the meme I was looking for. Um, it's okay. So this is the meme for it. It explains. I'll give you a moment to read it. So SQL injection is when you have a front end website and you have a text box for people to put information into. And if they do this here, colon drop table students. So what happens is this, you quote Robert, quote parentheses. So if you take this and input it, it's going to take that code and put it in there, and it's going to see Robert, right? And then input Robert, but then we'll run the drops table statement. So we'll actually drop the table. And that's bad.
So how does a front end developer stop that from happening then?
Store procedures.
Okay.
Store procedures. Because you can go. I mean, this is for a cybersecurity, but you can put code in here to stop that from happening. You can have it recognize things. Don't let don't let certain no quotes can be put in the responses. So there's a whole bunch of stuff you can do, but something simple like this would actually you could actually do something like that. I'm not going to do it, but you could. So, and when you have the code sitting in on your front end in your application or database, it's very easy to do that. So that's what sort of procedures come into play for.
So would you say procedures are pretty commonplace then
Yeah.
in the industry?
Yeah,
Okay.
they're the standard.
Because because you mentioned some front end developers will put this sort of SQL code into their front end code,
Yes.
but if it's a standard procedure to have the procedures, sorry for lack of a better term.
No, you're good. No, I'm not. I'm laughing. I'm laughing. I'm laughing at what I'm about to say. You're absolutely right. The standard is create store procedures for your code. However, developers tend not to write store procedures, and they don't want to go to the DBAs to write stored procedures. They're just, we'll put the code in our website and it'll be fine.
Okay.
So just because I've had many conversations with developers when they're like, "Oh, we'll just put the code in the website." No, you're not putting any code in any web app or any application. I'm making a stored procedure. You're going to call the stored procedure, and we're not going to play these games because it's safer, it makes more sense, and it's better for the database. But there transgression not transgression sidebar. So in the world of IT, everyone gets stovepiped, which means everyone kind of gets isolated in what they're doing. They don't talk to anyone else. And what'll happen with developers or DBAs or anyone really, they'll get into their own heads and just start hammering out the code and not thinking to ask anyone else or talk to anyone else and check things. So it's easier for them at that point just to put the code they want into the C# code or the Java code or whatever it is without going to talk to someone else. That's why when the companies you're looking for that you work with, you want to find that they've got peer review. You want to find that they have collaborative efforts to write code as opposed to one person doing it, because then you're going to get the best code that works the best. Like I said, I've talked to developers before who just want the code in their apps. I'm like, no, we're gonna make the stored procedures. So, it's the way it should be. But as with all things, free agency gets in the way sometimes.
That's fair. That's fair. So it's kind of a laziness thing, kind of a I don't want to talk to other people, introvert kind of.
I don't know. It's possible. It's partially that, but sometimes it's I know better than anyone else. I'm just gonna do it my way.
Oh, okay. Okay.
That gets in the way a lot. Matter of fact,
That's fair.
my day to day and my day job was all about a guy who used to work for us 6 years ago who decided to do a bunch of things his way, and now I got to change everything back.
Mm,
Yeah. But this, I mean, this is a key and critical skill, writing stored procedures. Um, let's look at this one here. This one's different because here I'm creating a procedure called SP count films in category. I'm doing an input variable, category name varchar 50, and an output variable, which means this one's going in and this one's coming out. So when I ran this one, I got a table back. When I run this one, I'm going to get a single value. So I'll create this stored procedure. And now I've got my call statement is a little different. I'm calling SP count films in category. I'm giving it the category action, but I have a variable declared. So variables are declared using an @ sign and then words after. I think last week I told you that this is a variable and this is a system variable. So these are all system variables. Whenever you see the double @ signs, this just returns the version of MySQL you're on. But here I'm declaring this is a variable. I'm not giving it a data type. I'm just saying it's just a kind of a varchar thing. And then I run this and I get it out by having select the film count as total film action films. And I run that. And now I know that's 64. I can run this without the select statement, but it doesn't do anything. It just says it got completed successfully. And the value doesn't come out until I put it in a select statement. So again, I create procedure, give it a name, and in parentheses, I give it an input and an output, and the value, the data types of both. Got my begin and end statements, and then I write the query that I want. And this is what the output is. I don't have to say that. I don't have to say p films equals this. This is returning one value.
you have multiple ins or multiple outs in a
Yep.
procedure.
Yep. You have multiple ins and multiple outs, as many as you want. I don't think I have an example of that, do I? Yeah, I've got one here with 2 outs. We'll get down to that one in a second. So here, let's So let's look at this one here. Creating a procedure, get customer payment stats, inputting customer ID. Here I'm declaring I'm declaring a variable called v total payments. I'm sorry, I'm declaring a table, v total payments. So here I'm selecting the sum amount into v total payments from payments, where customer ID equals customer ID. So this is, if I'm doing this on its own. Oh, I have to use the, I forgot I have to get, I've got the input variable there, right? So I'm getting the sum where the customer ID is what I put in into little, this is more of an array than a table. It's not a variable because there's no @ sign in front of it. I'm doing into, so it's more of like a little table thing. And then here, I'm creating a value set to be returned. I'm selecting the return to be the customer ID, the total payments that this one is, and then the average amount and the max amount from payment where customer ID equals customer ID. So this is a little on the sweetly complicated side. So I'm running this to get the total amount of the customer's payments. And then I'm taking that value into this query here and returning the average amount of their payments and the highest payment they ever made. Does that make sense? Okay, and then I'm gonna do for customer number 1. So customer 1 spent $118. Average payment is $3.70. Maximum payment is $10. So you see how that worked? And I can do that I can change the ID to whatever I want and run it again. Okay. The last one we're going to do tonight. Oh, no, next last one. So this one here. This little short here. Okay, this one. Creating the procedure. Get summary. I'm inputting the customer ID and I'm outputting the full name and I'm outputting the total spent. So here I'm selecting the concatenation of the name into the variable full name, which is right here, from customer or customer ID equals customer ID. And then I'm selecting the sum of the payment based on the customer ID into total spent. And I'm ending it. So here I've got 2 output variables and I'm giving them I'm putting the values into it specifically. I'm not letting it just go in because it's the only thing that's coming out. Here I got 2 of them. I'll create this procedure. And down here, I'm calling that I'm putting in customer ID 5. I'm making a variable called customer name. I'm making a variable called customer spent. And then I got my select statement. Selecting customer name as customer spent as total spent. I want to execute that for customer 5. That's what I get. Now here's the last one for reals. So this one here, this is using an if statement. We haven't really talked about if statements, but you all know what if statements are, right? If then. Create my procedure. Customer ID as an integer. The out is status. I'm declaring v total as a variable. I'm inputting the sum of the customer's payments, like this one did up here. I'm using the customer ID to get the total of their payments, putting this v total. If v total is greater than $150, they're a VIP customer. Else if 75, they're a value customer. Else status is standard customer, and then end. So if is a question, else if it's a question, and else is a statement. So here, if it's $150, they're VIP. If it's $75, they're a value customer. If they're anything else, it's a standard customer, and then we end it. So I create this procedure. And I've got two. I've got one for Mary Smith and one for Lorraine Stevens. And I run them both. One's valued, one's at VIP, and one's valued. Okay. How are we on understanding stored procedures? All we're doing is writing queries and encasing them in a create procedure and passing in the variables. What are you gonna say, Taylor?
I was just saying, yeah, the concept makes sense. It is a little confusing. I didn't even think this was something that you could do in SQL, so this is really
Oh, yeah.
cool to learn.
This isn't something that's ever brought up in this class, but I felt it important to talk about today.
Oh, is this? I haven't done the reading this week. Is this not in the reading this week
Oh
then?
no, this is completely outside the reading.
Oh, wow, okay.
So this is one of those things that I do sometimes. I'll start preparing my. I never do the same thing twice in these evening sessions. I always write fresh code because it keeps me on my toes. Right. This is the only chance I get to write code anymore, and it's not fancy code. Does I mean it demonstrates what's being done. So when I was preparing the code today, I'm like, I really should talk about stored procedures because I never did. And you guys are doing final projects, and in your final projects, and like with Michael's like really serious about his project. He's writing a front end to it. I'm like, I should talk about stored procedures because this is an important part of being a database designer, understanding the stored procedures that get made. And they are confusing when you think about it because um, if you think about you when you think about code like this, right? Like I take this code right here. Let me go back up here. Right, I just got this code right here. I can go and create a stored procedure around that without get down here and get my wording. Okay, so go back here. So I can take. Let me take this one here. Okay, so I can create this procedure, and I'm going to call this get um, customer. Dang it. And I get rid of this because we're not putting any values in, right? And then I go down here and I put end. And get my little more thing down here. And I create this. And it just creates it. And I just go call and then call this. Did you not work? Did you not work for me? What are you doing for me here? Come on. Oh. Hmm. Anyway, I don't know why this isn't working, but rule one is don't write code on the fly. It never goes right. Anyway, so you can take any query and just put it in the create procedure and then use it over and over again, right? And then you just get fancy and add variables to it. But this is a key and critical element to database development, so that you can have that code run. And again, it can run all the time. any number of times. It's compiled already. You're requiring the value to be put in there. So you're and if you're thinking of what you do front end, if you're looking for customer ID, it'd be a drop down, not a not a it would be a drop down, not a text box. Or you can have a drop down with the customer's name and have it look up the ID and then put that in there. So there's a lot of things you can do with it. But again, it's not part of this course. I don't think anywhere you're going to see talking about stored procedures here. But I just threw this little nugget at the end to show you there's a lot more that these databases can do. You doing good, Michael?
Yep.
Yep. Oh, do you guys have any questions, comments, concerns, thoughts, anything for the good of the order? Any questions on final projects? Any questions on anything for the course?
I did have a quick question.
Sure.
So I'm working on a way to like update the information for different people. So like if they promote to a new rank, or um if something about their profile needs to change, maybe they got a new email, what
Hmm.
would be the best way, um, like kind of on a, do you think, sorry, let me rephrase. What would be the best way, the best looking way to do that?
From the front end perspective or the back end perspective?
Yeah, like kind of from the front end in a way that'll work with the back end.
So in the front end, I would probably, let's say you're looking at like anything like any website where you got to change like your contact information, right?
Right.
So I would have a feel like bring up the page and say like, what's the old email address and what's the new email address? Or this is for like personal information. So I would definitely do that. And then I would have a stored procedure in the back that like update student where to set email address to new email where old email address is old email address. And then that would be the simple way to do it, right? So you've got your fields on the front end that field into the stored procedure on the back end. What I probably would do to make it a little more robust is that stored procedure. I would have a history table, and I would track the changes of that database. So let's say Bob Jones is changing his email address. So I have a stored procedure that let's just write it for funsies. So I'd have uh, um, create procedure. I'm gonna call it SP email change. And then I would input in, I would say old email, uh, in new email. Begin, update, uh, student set email equal to new email where email equals old email. But so that would be like the bare minimum to do. But I would also like insert into history. Um, select ID name, uh, email from, actually, I would probably do this first, actually. From student, do, uh, uh, date from student where email equals old email. And then update the student and then end that. Because if I'm making changes on a database, one of the most important things I need to do is track those changes. Because if something goes wrong, I want to be able to revert back to the old one. Like if I get an email that Bob's email isn't working, I might want to revert to the old email to see if that's the case. Also, if you're doing something like rank, you definitely want to keep a history of that. So you'd have a store procedure, you'd have a page that says like you get cadet's name and then new rank and hit submit. And then behind the scenes, you're tracking the date where that went from sergeant to what is that for whatever the ranks are, private to sergeant, and then tracking those dates in there. Did that you understand?
And yeah, can you like what exactly is history?
I just
Is
that's
that
a
a
table. I
table?
would have a table called history.
Okay, that makes sense.
Yeah. So one of the things, I mean, this is when you're a lot of times when you've got a database where things change a lot, you want to keep track of those changes. So you'll know who made the changes, when they made the change, and things like that, right? Because you don't want Bob to go in there and change his own rank. And
Right.
you don't want someone to put like the wrong rank in by accident. You don't like, he doesn't go from private to general. They just because they fat fingered it, right? So you want to be able to track the changes in a separate table. And usually, I'm just giving an example, like the table called history or like rank changes or rank history or something like that. But particularly if you're doing anything that has any kind of compliance issues with it, um, like for example, in my day job, I deal with databases that are in the finance part of our company. So any change made to a table needs to be tracked, sent to a tracking table, so I can say who'd made that change when.
Right. Okay.
So
And
this is just like rough code. I'm just playing my like skeleton code here. But yeah, that's what that is.
yeah, okay. And then would that procedure be actually in the SQL or
Yeah,
would that be in
yeah,
the okay.
yeah. So and then you just when you so like if like let's say this was the code, the query here, this one here, right, was in your code, like you were using this one. So this would be on the SQL server, and you would run this from your program.
Okay. I see.
Mhm. And then you just put the values in whatever values you're using for real. You put it like that wouldn't be a five; it'd be the value from your program.
Okay, that makes sense.
Mm-hmm.
Awesome. Thanks.
All right, cool. Any other questions? All right. Well, then I'm going to give you 14 minutes back your evening. Thank you for coming out tonight. Hope you guys had a good Halloween. And if you have any questions, you know you can hold me.
Okay,
Great.
thank you so much.
Thank
Thank
you.
you.
Take care, guys.